Hello student, in the last video we have completed the question number 1, that is example from 1 to 25. Now we'll see the question number 2. Integrate the following functions with respect to x. I is equals to integral cos of 3x minus cos of 4x upon sine of 3x plus sine 4x. Now see this example. That is the cos of 3x minus cos of 4x upon sine of 3x plus sine of 4x. Now here we will apply the formula for the cos of c minus cos d. That is equals to minus 2 times sine of c plus d upon 2 into sine of c minus d upon 2. To the denominator, we will apply the formula for the sine of c plus sine d. That is a 2 times sine of c plus d upon 2 into cos of c minus d upon 2. And that comes, here is a minus 2 sine of 7x upon 2 into sine of minus x upon 2. And here is a sine of minus theta. Sine of minus theta is a minus sine theta, and this minus minus will become plus. And to the denominator, here is a 3x plus 4x, that is a 7x upon 2, and cos of 3x minus 4x upon 2, that is a minus x upon 2. Now see this here. Here is a minus sine of minus x by 2, that become plus, and sine of 7x upon 2 upon sine of 7x upon 2, that get cancelled. Therefore, you will get sine of x upon 2 upon cos of x upon 2, and that will be the tan of x upon 2. Here is the tan of x upon 2. Now integrate this. I is equals to integral cos of 3x minus cos of 4x upon sine of 3x plus sine of 4x dx. That is equals to tan of x upon 2 into dx, and the integral of tan of x or tan of x by 2, that is, it is a log of 1 upon 2 log of sec of x by 2 plus c. Therefore, 2 log of sec of x upon 2 plus c, and this is the answer. That is a 2 times a log of sec of x by 2 plus c. And here is the answer. Again, you can see this on the board. See this here, I is equals to cos of 3x minus cos of 4x upon sine of 3x plus sine of 4x. Here we will apply the formula for cos c minus cos d minus 2 times sine of c plus d upon 2 into sine of c minus d upon 2 upon 2 times sine of, and the formula for sine c plus sine d, that is a 2 times sine of c plus d upon 2 into cos of c minus d upon 2. Therefore, you will get, that is the minus 2 sine of 7x upon 2 into sine of minus x upon 2. That is a 2 sine of 7x upon 2 into cos of minus x upon 2. Now here is the sine of minus x upon 2. We know the formula, sine of minus theta is equals to minus sine theta, and that's why here this minus minus will become plus, and here is a plus sign. And sine of 7x upon 2 and sine of 7x upon 2, that get cancelled, and to the numerator you will get sine of x upon 2 upon, and here is again cos of minus x upon 2, but formula for the cos of minus x, cos of minus theta is cos theta, and therefore here is a cos theta, and sine of x upon 2 upon cos of x upon 2, that becomes tan of x upon 2. Now we'll integrate this, that is I is equals to integral cos of 3x minus cos of 4x upon sine of 3x plus sine of 4x dx, and the value of this is a tan of x by 2, and its integral is a log of sec of x upon 2 into, that is a 1 upon the derivative of x upon 2, which is 1 upon 2 plus c, and whole answer I is equals to 2 log of sec of x upon 2 plus c. This is the answer. Now the next problem is second. I is equals to integral cos x upon sin of x minus a dx. Now in this case, we adjust the numerator angle just like of the denominator. Means what? Here is a cos of x, and what about the denominator? The denominator has the angle x minus a. Therefore, we will write here the angle x as x minus a by adjusting plus a and the minus a. Therefore, I had adjusted here I is equals to integral cos of x minus a plus a. Now see this here. म्हणजे डिनोमिनेटरला जो साइन थिटाचा अँगल दिलेला असेल तोच आपण न्यूमरेटर मध्ये घेणार आणि इथे इंटिग्रल कॉस ऑफ एक्स मायनस ए प्लस ए अपॉन साइन ऑफ एक्स मायनस ए. जर आपण जर याचं एक्सपान्शन केलं तर आपल्याला कॅन्सलेशन टर्म तिथे मिळतात आणि इंटिग्रेशन आपलं सॉल्व्ह होत असतं त्याच्यात. दॅट इज अ कॉस ऑफ एक्स मायनस ए इंटू कॉस ऑफ ए मायनस साइन ऑफ a into sin of x minus a upon sin of x minus a dx. Now here, this is the expansion of cos of a plus b. That is the cos of x minus a into cos a minus sin of a into sin of x minus a. Now split up these and there will be the cancellations of the terms. That is the cos of x minus a into cos of a upon sin of x minus a minus sin of a and sin of x minus a upon sin of x minus a. Now in this case, cos of x minus a upon sin of x minus a get cancelled. You will get cos of a into cot of x minus a dx, and the next term is sin of a dx. Now see this here, cos of x minus a upon sin of x minus a, that becomes cot of x minus a, and here is a cos of a minus, again here sin of x minus a upon sin of x minus a get cancelled, and you will get sin a. Now integrate this. The integral of cot of x minus a, that is cos a is a constant, cot of x minus a dx minus sin a is again constant, integral of the dx, and that's why you will get the integral of cot is log of sin of x minus a, and here is the integral of 1 is x. Therefore see this here, cos of a log of sin of x minus a minus x sin a plus c, and this is the final answer. Therefore I is equals to cos of a log of sin of x minus a minus x sin a plus c. Now see this, the same answer I will repeat here. This is the I is equals to integral cos x upon sin of x minus a, and again the angle of this sign, which is x minus a, will adjust to the numerator. Therefore cos of x minus a plus a, expand this, that is the cos of, here is the first term is, this is the a and this will be the b. Now expand this, then you cos of a plus b, that formula is the cos of x minus a into cos of a minus sin of a and here is the expansion. Now split up this, that is integral cos of x minus a into cos a upon sin of x minus a minus sin a into sin of x minus a upon sin of x minus a, and cos of x minus a upon sin of x minus a, it becomes cot of x minus a into cos of a, minus sin of x minus a upon sin of x minus a get cancelled, you will get sin of a dx, and therefore cos of a into integral cot of x minus a dx minus sin of a integral 1 dx. Now what is the integral of cot of x minus a? That is a log of sin of x minus a minus integral of 1 is x, and therefore it is a minus x sin a plus c, and this is the final answer. That is I is equals to cos a into sin of x minus a minus x sin a plus c. Now the next example. Example number 3. I is equals to sin of x minus a cos of x plus b. Now here the denominator cos of x plus b, this is the angle which is the cos of the angle is x plus b. Now to the numerator the sign has the angle x minus a. Therefore we will write this x minus a as x plus b minus a minus b in this form. See this here. X plus b minus a minus b cos of x plus b dx. Now here is a sin of x plus b minus in bracket a plus b bracket complete upon cos of x plus b. Sorry, here by mistake it is the, I think this a, there must be the b. I will adjust here. Now expand this sin of x plus b minus a plus b. Here is a cos of change this angle x plus b cos of x plus b. Again split up this, that is in bracket sin of x plus b into cos of a plus b upon cos of x plus b minus sin of a plus b into cos of x plus b see this here cos of x plus b upon cos of x plus b bracket complete into dx. Now the cancellations of the terms are sin of x plus b upon cos of x plus b, it becomes tan of, here is a cos of a plus b into tan of x plus b minus sin of a plus b cos of x plus b upon cos of x plus b get cancelled. Now integrate this, that is the cos of a plus b integral of tan of x plus b is a log of sec of x plus b, and integral of sin of a plus b, this is the constant, that is the x into sin of a plus b. The screen is not constant, plus c. This is the final answer, that is the I is equals to. Now we'll see again the same questions. I will repeat here. I is equals to integral sin of x minus a upon cos of x plus b dx. Again the angle, that is x plus b, is adjusted here. That is a sign in bracket x plus b minus a minus b, because here we have the minus a, that's here is a minus a, here is a plus b and minus b. These two are adjusted here. Now expand this sign of a minus b. Sin of a minus b is sin a cos b minus cos a sin b upon cos of a plus b, and now here is a sin of x plus b upon cos of x plus b. It becomes tan of x plus b. Here is a cos of a plus b minus, now here is a sin of a plus b, and here is a into the cos of x plus b. These two terms get cancelled. You will get minus sin of a plus b dx. Now integrate this. What is the integral of tan of x plus b? Is a sec of log of sec of x plus b, and this is a constant, therefore its integral is x into sin of a plus b plus c, and this constant is also again as it is, that is I is equals to cos of a plus b into log of sec of x plus b minus x into sin of a plus b plus c. Now the next is and here is a problem number 4. I is equals to integral dx upon sin x into cos x plus 2 cos square x. Now in this example, we will divide numerator and the denominator by cos square x. Therefore dx upon cos square x, sin x into cos x plus cos square x whole divided by cos square x. Now next step is that is a dx upon cos square x, it becomes sec square x into dx. Sin x into cos x upon cos square x, that's one cos get cancelled. You will get sin x upon cos x, which is the tan x. And here is a cos square x upon cos square x, it becomes 2. Therefore, we get here sec square x dx. Here is a tan x plus 2, and we will have the substitution. Tan of x is equals to t, and we can solve this integration. Tan of x is equals to t, thereby its derivative is a sec square x into dx is equals to dt. Therefore, I is equals to integral sec square x into dx upon tan of x plus 2. This is dt upon t plus 1, that is equals to log of t plus 2, t plus 1 plus c. By mistake, here is a 1. This is 2. Therefore, the answer is I is equals to log of tan of x plus 2 plus c. Therefore, I is equals to log of tan of x plus 2 plus c, and this is the answer. See this again. I is equals to integral dx upon sin x into cos x plus 2 cos square x, divide n and divide cos square x. That is I is equals to dx upon cos square x, it becomes sec square x into dx, and sin x into cos x upon cos square x, and that becomes cos get cancelled. You will get sin x upon cos x, and here is a cos square x upon cos square x, that becomes 1. Therefore, integral sec square x dx tan x plus 2. Now put tan of x is equals to t, sec square x into dx is equals to dt. Therefore, I is equals to integral sec square x into dx upon tan of x plus 2, that is equals to integral dt upon t plus 2, which is log of t plus 2 plus c. And hence, the answer is I is equals to log of tan of x plus 2 plus c, that is I is equals to log of tan of x plus 2 plus c. Now the next example is example number 5. I is equals to integral sin theta plus 2 times sin x plus 2 times cos x upon 3 sin x plus 4 cos x dx. I forget to write here dx. I will write now next. Here the numerator is equals to a into denominator plus b into derivative of the denominator. That is, we express the numerator in this form: a into denominator plus b into derivative of the denominator. What is the numerator? Sin x plus 2 cos x is equals to a into denominator, which is 3 sin x plus 4 cos x plus b derivative of the denominator, that is the 3 cos x minus 4 sin x. Now the normal simplification is here: 3a minus 4b sin x plus 4a plus 3b cos x. And now we will equate the coefficient of sin x and the cos x. To the left hand side, the coefficient of sin x is 1. To the right hand side, it is a 3a minus 4b. Comparing the coefficient on both sides of not sin theta, but it is the sin x and the cos x by mistake. That is a 3a minus 4b. Here is a 1. Therefore 3a minus 4b, that is equals to 1. Coefficient of sin x is 3a minus 4b, and to the left hand side it is 1. Therefore 3a minus 4b is equals to 1. What about the cos x? The coefficient of cos x to the right hand side is a 4a plus 3b, and here is a 2 to the left hand side. Therefore 4a plus 3b is equals to 2. Now we will solve these two linear equations, equation number 1 and equation number 2. Multiply equation number 1 by 3 and 2 by 4 and add these two equations. Then you will get 9a minus 12b is equals to 3. 16a plus 12b, 16a plus 12b is equals to 8. Now add these two equations, that is the 25a is equals to 11. Therefore a is equals to 11 upon 25. Substitute the value of a in the equation number 1. Therefore 3 into 11 upon 25 minus 4b is equals to 1. That is 33 upon 25 minus 1, which is 8 upon 25 is equals to 4b. Therefore b is equals to 2 upon 25. Therefore the integral become, see this, a into numerator is a into denominator plus b into derivative of the denominator, that is a d dash upon denominator dx. If we evaluate this, that is a d upon d is 1 and here is a plus sign dx, b d dash upon d dx, d dash is the derivative of denominator. Therefore its integral is a, here is a 1 d upon d is 1 dx plus b log of d plus c. Integral of 1 is, that is x, and the value of a is 11 upon 25x plus 2 upon 25 log of d plus c. The value of the d is a 3 sin x plus 3 sin x plus cos x plus c, that is 11 upon 25 plus 2 upon 25 log of, here is a 4, 3 sin x plus 4 cos x plus c. Now here is a 25 in the textbook, it's a different number, but I think that 25 is the correct one. Next is and once again see this question. Question number 5, I is equals to integral 3 sin x plus 2 cos x upon 3 sin x plus 4 cos x. This is the numerator. That is, we express the numerator in this form. That is a into denominator plus b into derivative of the denominator. Now here is a sin x plus 2 cos x, a denominator 3 sin x plus 4 cos x, b derivative of the denominator. That is the derivative of sin x is a cos x, 4 cos x is a minus sin x multiplied, that is a 3a sin x, 4a cos x, 3b cos x minus 4b sin x. Collect the terms of the sin x, 3a minus 4b sin x. Collect the term of the cos x, that is a 4a plus 5b cos x. Comparing the coefficient of sin theta, not sin theta, it is a x here. Comparing the coefficient of, it is a x, I can write here x, comparing the coefficient of x on both sides. Okay, then you will get the equations 3a minus 4b is equals to 1 and 4a plus 3b is equals to 2. Multiply equation number 1 by 3 and 2 by 4 and evaluate this. That is, you will get 9a minus 12b is equals to 3. 16a plus 12b is equals to 8. Add these two equations, you will get the value of a 11 upon 25. And the next is substitute the value of a in equation number 1, that is a 3a minus 4b is equals to 1. That is 11 upon 25. 33 upon 25 minus 1 is equals to 4b, which is 8 upon 25 is equals to 4b. b is equals to 2 upon 25. Therefore, our form is I is equals to integral. This is the numerator and this is the denominator. Separate it. Then a integral d upon d dx plus b integral d dash upon d dx. Therefore, integral of 1 dx plus b. This is the d dash upon d, which is the log of d plus c. That is, the value of a is 11 upon 25, 1, this x, 2 upon 25 log of 3 sin x plus 4 cos x plus c, and this is the answer. Now the next problem is problem number 6. I is equals to integral 2 plus 3 tan x. Now here is again the numerator is equals to a into denominator plus or we'll simplify it in this form. That is a 2 plus 3 sin x upon cos x. If you simplify it, then you will get integral cos of x upon 2 plus 3 sin x dx. Now here numerator is equals to a into denominator plus b into derivative of the denominator, where n is a numerator and the d is a denominator. Now what is the numerator here? The numerator is cos x. Cos x is equals to a into denominator. The denominator is a 2 cos x plus 3 sin x. 2 cos x plus 3 sin x plus b into derivative of the denominator. What is the derivative of denominator? That is the derivative of cos x is minus 2 sin x plus 3 cos x plus 3 cos x. Now equate the terms of cos x and sin x. Here is a cos x, that is a 2a plus 3b into cos x, and the remaining terms are 3a minus 2b sin x. Now on the left hand side, the sin of x term is absent, therefore 0 is equals to 3a minus 2b is equals to 0, and 2a plus 3b is equals to 1. Comparing, that is a 2a plus 3b is equals to 1, 3a minus 2b is equals to 0. Now solve these two equations simultaneously. This is equation 1, equation number 2, multiply equation number 1 by 2 and 2 by 3, that is a 4a plus 6b is equals to 2, and 9a minus 6b is equals to 0. Add these two equations, that is 13a is equals to 2, therefore a is equals to 2 upon 13. Now put the value of a in equation number 1. For any equations, that is 3a minus 6b is equals to 2b. The value of a is 2 upon 13, that is equals to 2b. Therefore b is equals to 3 upon 13. This is the value of b. Therefore our integral become, that is the integral I is equals to integral cos x upon 2 cos x plus 3 sin x dx. Numerator is equals to a into denominator plus b into derivative of the denominator, that is a d dash. This is in a very simplified form upon d. It is not necessary to write again the whole terms. You can write this symbolically also. Upon d dx. Therefore a, that is a, this d upon d is 1. Therefore a into integral of dx plus b into integral of d dash upon d dx. Now what is the integral of dx is x, that is ax plus b integral d dash upon d, that is a log of d plus c. Substitute the value of d and substitute the value of a. Here is a 2 upon 13x plus the value of b is 3 upon 13 log of d, and the value of d is 2 cos x plus 3 sin x plus c. Therefore, I is equals to 2 upon 13x plus 3 upon 13 log of 2 cos x plus 3 sin x plus c. I is equals to integral dx upon 2 plus 3 tan x. This tan x can be written as sin x upon cos x. That is a 2 cos x plus 3 sin x integral cos of x 2 cos x plus 3 sin x. Numerator is equals to a into denominator plus b into derivative of the denominator. N is equals to numerator, d is a denominator, and d dash is a derivative. Now here is a cos x is equals to a 2 cos x plus 3 sin x plus b derivative of the denominator, that is a minus 2 sin x plus 3 cos x. Now we'll equate the terms of cos x and sin x. Now here is a 0 sin x plus cos x is equals to, collect the term of the cos x, that is a 2a cos x, and here is a 3b cos x, and take cos x as common, then you will get 2a plus 3b cos x plus 3a minus 2b sin x. And now compare the coefficient of sin x and cos x. If we compare the coefficient of cos x, then you will get the equation 2a plus 3b is equals to 1. And compare the coefficient of sin x. To the left hand side, sin x is absent, therefore here is a 0. Therefore 3a minus 2b is equals to 0. Therefore this is equation number 1 and equation number 2. We'll solve these two equations simultaneously. Multiply equation number 1 by 2 and 2 by 3. Then you will get 4a plus 6b is equals to 2. 9a minus 6b is equals to 0. Add these two equations. You will get 13a is equals to 2. A is equals to 2 upon 13. Substitute the value in this equation, that is the 3a minus 2b is equals to 0. Therefore 3a is equals to 2b. The value of a is 2 upon 13. Therefore b is equals to 3 upon 13. Therefore I is equals to integral cos x upon 2 cos x plus 3 sin x, that is the integral. This is the numerator. We have expressed the numerator in this form, that is the numerator is equals to a into denominator plus b into derivative of the denominator. Therefore numerator is a into d plus b into d dash upon d. Separate it. D upon d, that is 1, a into integral of dx plus b into integral of d dash upon d dx. Therefore integral of dx is x, ax plus b. This is a log of d plus c. The value of a is a 2 upon 13x plus b is a 3 upon 13 log of 2 cos x plus 3 sin x plus c. And you will get this answer, that is I is equals to 2 upon 13x plus 3 upon 13 log of 2 cos x plus 3 sin x. Now the next example. Seventh example. I is equals to integral 4 into e raised to 3x minus 25 upon 2 e raised to x minus 5 dx. Now the same type of the problem is again n is equals to a into denominator plus b into derivative of the denominator, which is a d dash. Now 4 e raised to x minus 25 is equals to a 2 e raised to x minus 5 plus b. The derivative of the denominator, that is the derivative of e raised to x, is e raised to x. Therefore I am writing here d dx of 2 e raised to x minus 5. Therefore 4 e raised to x minus 25 is equals to a 2 e raised to x minus 5 plus, here is a derivative, that is the derivative of 2 into e raised to x is 2 e raised to x, and collect the terms of e raised to x. Now here the terms of the e raised to x, that is the 2a e raised to x and 2b e raised to x. Collect the e raised to x, that is the 2a plus 2b into e raised to x minus 5a. Therefore here is e raised to x, e raised to x. That is the 2a plus 2b is equals to 4. Therefore a plus b is equals to 2. See this again here. the value of a will be 0 because here is a minus 25. That is 5a minus 5a is equals to minus 25. Therefore, a is equals to 5. Comparing the coefficients of a mistake. So, comparing the coefficient of e raised to x, that is 2a plus 2b is equals to 4. This is first. Now compare the coefficient of the constant, that is minus 5 is equals to minus 25. That become plus a is equals to 5. Substitute the value of a here. You will get the value of b. 2 into 5 plus 2b is equals to 4. That is 2b is equals to 4 minus 10, that is a minus 6. Therefore, b is equals to minus 3. Therefore, I is equals to integral let's say the 4 e raised to x minus 25 upon 2 e raised to x minus 5 dx. Again, here is a into denominator plus b into derivative of the denominator upon d dx. Therefore, a into integral of this d upon d dx. Split up this b into integral d dash upon d dx. D upon d is 1, that is integral of 1 dx is x, and d dash upon d, that is the log of d. Therefore, here is a ax plus b log of d plus c. Substitute the value of d, b, a. You will get the answer. That is I is equals to 5a minus 3 log of d, which is denominator. That is a 2 e raised to x minus 5 plus c, and hence the answer. Therefore, I is equals to 5x minus 3 log of 2 e raised to x minus 5 plus c. Now the next is, see this again here. That I is equals to integral 4 e raised to x minus 25 upon 2 e raised to x minus 5. Again, this numerator is equals to, that is a into d plus b into derivative of the denominator, that is a d dash. Therefore, we have expressed this, that is a 4 e raised to x minus 25 a into 2 e raised to x minus 5. This is the first. Again, here is its derivative, that is a 2 e raised to x minus 5. What is the derivative of 2 into e raised to x minus 5? That is a 2 e raised to x, derivative of 5 is 0. Now compare the coefficient of a and b. Simplify first of all this. That is a take e raised to x as common. That is a 2a plus 2b into e raised to x, and here is a minus 5a. Again, e raised to x minus 25. Here is again minus 25. Now compare the coefficient of the constant and e raised to x. On the both sides, on the left hand side, the coefficient of e raised to x is 4, and the right hand side is 2a plus 2b. Therefore, 2a plus 2b is equals to 4. And what about the constant? Minus 25 is equals to minus 5. Therefore, 5a is equals to 25. A is equals to 5. And substitute the value of a. You will get the value of b, which is minus 3. Therefore, here is I is equals to our integral 4 e raised to x minus 25 dx upon 2 e raised to x minus 5. Therefore, here is a numerator. What is the numerator? Numerator is always in this form. that is n is equals to a into denominator plus b into derivative of the denominator. Again it is like this, written is like this. Split up it, a into integral d upon d dx plus b integral d dash upon d dx. That is a integral 1 dx plus b d dash upon d dx. What is the integral of 1? Integral of 1 is x plus b log of d plus c. Substitute the value of this d, 2 e raised to x minus 5 plus c. Therefore, I is equals to 5x minus 3 log of 2 e raised to x minus 5 plus c. This is the, now we will see the next example. Example number 8. I is equals to integral 20 plus 12 e raised to x upon 3 e raised to x plus 4. Again the same type of the problem. Numerator is equals to a into denominator plus b into derivative of the denominator. Instead of writing all the expressions, I had done in a very short form, that is a d dash, and like this. Numerator is equals to a into denominator plus b into derivative of the denominator. Therefore 20 plus 12 e raised to x is equals to a into d plus b into derivative of the denominator, that is a d dash. Therefore 20 plus 12 e raised to x is equals to, denominator is a 3 e raised to x plus 4 plus d dash, the derivative of the denominator, that is derivative of 3 e raised to x is 3 e raised to x, derivative of 4 is 0. Here is a 3 e raised to x, that is, we have here, see this here, that is a 3a plus 4b, sorry, 3a plus 3b into e raised to x. These are the coefficient of, that is a e raised to x. And what about the constant? This is a 4a. Here is a 4a. That is a 12 e raised to x plus 20. Now compare left and right hand. Comparing the coefficient of e raised to x to the left hand and the constant. The 4a constant is 4a is equals to 20. You will get the value of a directly. A is equals to 5. A is equals to 5. Now compare the coefficient of e raised to x on the both sides, left and right. That is 3a plus 3b is equals to 12. Divide by 3. You will get a plus b is equals to 4. A plus b is equals to 4. What is the value of a? A is 5. Therefore b is equals to 4 minus 5. That is equals to minus 1. B is equals to minus 1. A is equals to 5 and b is equals to minus 1. Again our integral. Integral, here is a numerator upon denominator dx in a very short form. Integral a into d plus b into derivative of the denominator upon d into dx, separated. That is a d upon d plus b d dash upon d dx. And what is answer? Answer is ax. Dt get cancelled. Integral of 1 dx plus b log of d plus c. Substitute the value of d on b, a and b. That is a 5x. Value of a is 5. Integral of 1 dx is x minus log of 3 raised to x plus 4 plus c. This is the answer. Now the next is, see this here. This is the problem number 8. I is equals to 20 plus 12 e raised to x upon 3 e raised to x plus 4. Again numerator is equals to a into denominator plus b into derivative of the denominator. Next is 20 plus 12 e raised to x, a into d plus b into derivative of the denominator. 20 plus 12 e raised to x. What is the denominator? That is a 3 e raised to x plus 4, and its a derivative is a b. Derivative of 3 e raised to x is, that is the derivative of 4 is 0. It's a 3 e raised to x. Now compare the coefficient of e raised to x and the constant. What about the constant? 4a is equals to 20. Therefore, a is equals to 5. A plus b is equals to 12. Therefore, a plus b is equals to 4. The value of b is minus 1. Therefore, our integral I is equals to integral n upon d. This is numerator, denominator. Numerator is expressed as a into d plus b into derivative of the denominator upon d. Separate it, then you will get a integral d upon d dx, which is 1 dx, and the value of a is 5. Integral of 1 dx is 5x. This is one. And the next is b d dash upon d. It's a log of d plus c, which is a log of the value of d is denominator. That is the denominator is the 3 e raised to x plus 4, which is a 3 e raised to x plus 4 plus c. In the textbook, here is answer, that is a minus 5x, but here is I check it is a plus 5x. If you are agree, then write down this. Otherwise, you follow from the textbook answer. Now the question number 9. Now here is a question number 9. That is 3 e raised to 2x plus 5 upon 4 e raised to 2x minus 5 dx. I forget to write dx. I will write. Now again, the numerator is equals to a into denominator plus b into derivative of the denominator. Every time we write for this type of the problems, 4 e raised to 2x minus 5, it's a derivative. Therefore, 3 e raised to 2x plus 5 a into 4 e raised to 2x minus 5 plus b. What is the derivative of e raised to 2x? The derivative of e raised to 2x is e raised to 2x into derivative of 2x is 2. That is b into 8 e raised to 2x. Now again the comparing with the coefficient of e raised to 2x and the constant. Therefore 4a e raised to 2x plus 8b e raised to 2x minus 5a. Therefore here is a 3 e raised to 2x in bracket 4a plus 8b into e raised to 2x minus 5a. Forget to write here plus 5 here. Comparing the coefficient of this is the e raised to 2x plus 5 and the constant. Therefore minus 5a is equals to 5. Therefore a is equals to minus 1. 4a plus 8b is equals to 3. We get the value of a is minus 1. Now 4a plus 8b is equals to 3. Substitute the value of a, which is minus 1. That is 4 into minus 1 plus 8b is equals to 3. Therefore minus 4 plus 8b is equals to 3. Therefore 8b is equals to 7. That is overall b is equals to 7 upon 8. A is equals to minus 1 and b is equals to 7 upon 8. The value of a is minus 1 and the b is 7 upon 8. Therefore, integral I is equals to n upon d, that is numerator upon denominator. Therefore, integral a into denominator plus b into derivative of the denominator, which is d dash upon d dx. Therefore, a into integral d upon d dx plus b integral d dash upon d dx. That is a into integral of 1 dx plus b integral d dash upon d, that is a log of d plus c. That is ax plus b log of d. Log of d plus c. Now write the value of a, b and d. That is a minus x plus 7 upon 8 log of d. The value of d is 4 e raised to 2x minus 5 plus c, and this is the answer. Therefore, I is equals to minus x plus 7 upon 8 log of 4 e raised to 2x minus 5 plus c. This is the answer. Now, series 3. Next is number 9. I is equals to integral 2 e raised to 2x plus 5 upon 4 e raised to 2x minus 5. 2 e raised to 2x plus 5. That is numerator is equals to a into denominator plus b into derivative of the denominator. That is, the term is as it is. The derivative of this denominator, that is a 4 e raised to 2x. What is the derivative of e raised to 2x? Derivative of e raised to 2x is e raised to 2x into 2, and 4 into 2 is 8. Therefore, b into 8 e raised to 2x. Therefore, 3 into e raised to 2x plus 5 is equals to 4a e raised to 2x plus 8b e raised to 2x minus 5a if we simplify the above step. Now we'll compare the coefficient of e raised to 2x on the both sides. To the left hand side, it is a 3 into e raised to 2x, and to the right hand side, it's a 4a plus 8b into e raised to 2x. Therefore, comparing, you will get that is minus 5a is equals to 5, therefore a is equals to minus 1. And the coefficient of e raised to 2x on the both sides is, that is the 4a plus 8b is equals to 3. Substitute the value of a and you will get the value of b, which is 7 upon 8. Therefore, integral I is equals to integral, that is the n upon d, numerator upon denominator. This is a very short form to write down. Integral a into denominator plus b into derivative of the denominator, that is a d dash upon d. Separate it. A into integral d upon d dx plus b integral d dash upon d dx. Therefore, d upon d is 1 dx plus b is the log of d plus c. Therefore, integral of 1 is x, that is ax plus b log of d plus c. Now, what is the value of a? A is minus 1 and b is 7 upon 8. Therefore, I is equals to minus x plus 7 upon 8 log of 4 e raised to 2x minus 5 plus c. Now, we'll see the next example. That is, I is equals to integral cos of x bracket cos of x raised to 8 and cos x upon sin x dx. Integral cos of x raised to 8 into cot x dx. Now, cos of x raised to 8 can be written as cos square x bracket raised to 4 cot x. But cos square x means what? 1 minus sin square x bracket is to 4 into cot of x. Next is expand this. One minus sin square x bracket is to 4 by using the binomial theorem, that is a 4c0 1 raised to 4. Next 4c1 sin square x bracket is to 1, 4c2 sin square x bracket is to 2, and again minus 4c3 sin square x bracket is to 3, 4c4 sin square x bracket is to 4. The value of 4c0 is 1, 4c1, the value of 4c1 is a 4. That is, here is a 4 sin square x plus the value of 4c2 is a 2. That is a 4c2, that is a 6. 6 into sin of x raised to 4 minus the value of 4c3 is again 4. That is a minus 4 minus 4 sin of x raised to 6 plus the value of 4c4 is 1 into sin of x raised to sin square x raised to 4, that is sin of x raised to 8. Now see this again, where writing these terms in this sequence. Here is a sin of x raised to 8 minus 4 sin of x raised to 6 plus 6 sin of x raised to 4 minus 4 sin square x plus 1. Last is plus 1. Therefore, I is equals to integral sin of x raised to 8 minus 4 sin of x raised to 6 plus 6 sin of x raised to 4 minus 4 sin square x plus plus 1 into cos of x upon sin x. Now divide to the all terms by sin x. Sin of x raised to 8 upon sin x minus 4 sin of x raised to 6 upon sin x plus 6 sin of x raised to 4 upon sin x minus 4 sin square x upon sin x plus 1 upon sin x into cos x dx. Therefore, integral sin of x raised to 7 minus 4 sin of x raised to 5 plus 6 sin of x raised to 3 minus 4 sin of x plus 1 upon sin x into cos of x dx. This is very simple. Put sin of x is equals to t. Therefore, cos of x into dx is equals to dt. Therefore, I is equals to integral t raised to 7 minus 4 t raised to 5 plus 6 t raised to 3 minus 4 t plus 1 upon t dt. Now integration t raised to 8 upon 8 minus 4 upon 6 t raised to 6 6 upon 4 t raised to 4 minus 4 upon 2 t square plus log of t plus c. Now substitute the value of t then to this simplification. T raised to 8 upon 8, 2 upon 3 t raised to 6, 3 upon 2 t raised to 4 minus 2t square log of t plus c. That is a sin of x raised to 8 upon 8 minus 2 upon 3 sin of x raised to 6 plus 3 upon 2 sin of x raised to 4 minus 2 sin of x square plus log of sin x plus c. Therefore, this is final answer. The textbook answer is different, but this is my answer. Now the again series here, that is integral cos of x raised to 8 into cos of x upon sin x dx. Now it is written as, that is a cos square x bracket raised to 4 cot x dx. Cos square x can be written as 1 minus sin square x bracket raised to 4 into cot x dx. 1 minus sin square x bracket raised to 4, 4c0 1, 4c1 1 sin square x bracket raised to 1, 4c2 sin square x bracket raised to 2 minus 4c3 sin square x bracket raised to 3 plus 4c4 sin square x bracket raised to 4. The value of 4c0 is 1, 4c1 is 4, 4c2 is 6, 4c3 is 4 and 4c4 is 1, and in this way we get the terms of sin of x raised to 8 minus 4 sin of x raised to 6 plus 6 sin of x raised to 4 minus 4 sin square x plus 1. Now here I is equals to integral sin of x raised to 8 minus 4 sin of x raised to 6 plus 6 sin of x raised to 4 minus 4 sin square x plus 1 into cos x upon sin x dx. Now this sin x will divide to the all these terms. Here is a cos x, that is a, after division you will get sin of x raised to 7 minus 4 sin of x raised to 5 plus 6 sin of x cube minus 4 sin x plus 1 upon sin x bracket complete cos x into dx. Put sin of x is t, that is the cos of x into dx is dt. I is equals to integral t raised to 7 minus 4t raised to 5 plus 6t raised to 3 minus 4t plus 1 upon t dt, and their integral t raised to 8 upon 8 minus 4 upon 6 t raised to 6, 6 by 4 t raised to 4 minus 4 upon 2 t square plus log of t plus c. And here this is the substitution. Resubstitute the value, then I is equals to sin of x raised to 8 upon 8 minus 2 upon 3 sin of x raised to 6 plus 3 upon 2 sin of x raised to 4 minus 2 sin square x plus log of sin x plus c. This is my answer, but in the textbook the answer is different. If you are agree, then write down this answer. Now the question number 11. Now the next problem is tan of x integral I is equals to integral tan of x raised to 5. There is a tan cube x into tan square x dx. Now this tan cube x, and it can be written as tan square x can be written as sec square x minus 1. This is again their multiplication, that is integral tan square x into tan cube x into sec square x dx minus integral tan cube x to dx. Now again this tan cube x can be written as tan of x into tan square x Here is a tan cube x, integral tan cube x into sec square x dx minus tan x, and again here is a tan square x can be written as sec square x minus 1. Here is again integral tan cube x into sec square x dx minus tan x into sec square x, and this minus minus will become plus tan of x dx. This is last is minus minus will plus integral tan of x plus dx. Now in this case put tan of x is equals to 2t, then its a derivative is sec square x, therefore it will become sec square x into dx, that is equals to dt in this case also, and we can find out the integral of tan of x, which is log of sec x, and the problem is solved. Now see this here, put tan of x is equals to t, therefore sec square x into dx is equals to dt. Therefore the first integral become tan cube x into dt minus integral tan of x into dt plus integral of tan of x is log of sec of x plus c, and now the integral of tan t cube. The integral of t cube is a t raised to 4 upon 4 minus t square upon 2 plus log of sec x plus c, and then we'll resubstitute the value of t, which is a tan x. Therefore tan of x bracket is to 4 upon 4 minus tan square x upon 2 plus log of sec x plus c, and this is the final answer. This answer. Now again we will see this answer here. I is equals to integral tan of x raised to 5. It's written as tan cube x into tan square x. Again tan square x can be written as sec square x minus 1. That is integral tan cube x into sec square x dx minus 1 into tan cube x, that is a tan cube x dx. Here is a tan into tan square x. Again this tan square x can be written as sec square x minus 1. Their multiplication tan of x into sec square x, and this minus minus will become plus integral tan of x. Now put tan of x is equals to 2, its derivative is sec square x into dx is equals to dt. Therefore this integral changes, that is a t cube into dt minus t into dt plus integral of tan of x is a log of sec x plus c. Here is a t raised to 4 upon 4 minus t square upon 2 plus log of sec x plus c. Resubstitute the value of the t, that is a tan of x raised to 4 upon 4 minus tan square x upon 2 plus log of sec x plus c, and this is the final answer. Now the next example, example number 12, integral cos of x raised to 7 dx. Now it is written as directly. Now see this here, I will show the first of all here. That is a 12 integral cos of x raised to 7 dx. It can be written as cos of x raised to 6 cos x dx, and cos of x raised to 6 can be written as cos square x bracket raised to 3 cos x. Cos square can be written as 1 minus sin square x bracket raised to 3 into cos x dx. Now put sin of x is t, and then it's a derivative cos of x into dx is equals to dt. Therefore I is equals to integral 1 minus t square bracket cube into dt. Now expand this 1 minus t square bracket cube, that is 1 minus 3t plus 3t raised to 4 minus t raised to 6 into dt. Now its integral, that is a t, integral of 1 is t, minus 3t is a minus 3t. Now here one mistake is that it is a minus 3t square. Therefore its integral is a minus 3t cube upon 3 plus 3t raised to 4, that is a 3t raised to 5 upon 5 minus t raised to 7 upon 7 plus c. Now again this is a simplified form. I is equals to, replace the value of the t, which is sin x, that is sin x minus sin cube x plus 3 by 5 sin of x bracket sin of x raised to 5 minus sin of x raised to 7 upon 7 plus c, and this is the answer. I is equals to sin x minus sin of x raised to 3, that is sin cube x, plus 3 by 5 sin of x raised to 5 minus sin of x raised to 7 upon 7 plus c. Now the next example is, you can see this also here, 31 minus sin square x bracket raised to 3 into cos x. Put sin of x is equals to 2. Again I am repeating here, cos x into dx is equals to dt 1 minus t square bracket raised to 3. Now this is expansion, it is a square, minus 3t square, and this is the final answer. Now the example number 13. That is a tan of 3x, tan of 2x, tan of x, I is equals to integral tan of three x into tan of 2x into tan of x dx. Now see, this is the formula, that is the 2x plus x is equals to 3x. Tan of 2x plus x is equals to tan of 3x. Therefore again this can be written as, what is the formula for tan of 2x plus tan of a plus b? That is a tan a plus tan b upon 1 minus tan of a into tan b. By mistake there is a minus sign. That is equals to tan of 3x. Here must be the minus sign. We'll replace it. Therefore tan of 2x plus tan x tan of 3x. Here I changed it, that's sign. Tan of 2x plus tan x is equals to tan of 3x in bracket 1 minus tan of 2x into tan x. Now again the simplification. Tan of 2x plus tan x tan of 3x minus tan of x into tan of 2x into tan of 3x therefore tan of 3x into tan of 2x into tan x is equals to tan of 3x minus tan of 2x minus tan of x. Now this is the value of tan of 3x into tan of 2x into tan x, and we want to find out the integral of this. Due to my digital board, it moves up and down, and therefore there is a problem. I is equals to integral tan of 3x into tan of 2x into tan x into dx. That is equals to integral tan of 3x minus tan of 2x minus tan x into dx. Now the integral is very simple. The integral of tan of 3x is 1 upon 3 log of sec of 3x minus 1 upon 2 log of sec of 2x minus log of sec x plus c, and this answer. Therefore I is equals to 1 upon 3 sec of 3x minus 1 upon 2 log of sec of 2x minus log of sec x plus c. See this again here. This was the problem number 13. You can take the screenshot of this problem also. 13, that is a integral tan of 3x into tan of 2x into tan x dx. We can write this 2x plus x is equals to 3x. Take tan on both sides. That is the tan of 2x plus x is equals to tan of 3x. What is the formula for tan of a plus b? Tan a plus tan b upon 1 minus tan a into tan b. That is the 1 minus tan of 2x into tan x is equals to tan of 3x. Therefore, the value of tan of 2x plus tan x is equals to tan of 3x in bracket 1 minus tan of 2x into tan x. Now, normal multiplication is here. Tan of 2x plus tan x is equals to tan of 3x minus tan of x into tan of 2x into tan of 3x. Therefore, tan of 3x into tan of 2x into tan x is equals to tan of 3x minus tan of 2x minus tan x. Now, take the integral of this. I is equals to integral tan of 3x into tan 2x into tan x. Therefore, integral tan of 3x minus tan of 2x minus tan x, and its integral. The integral of tan of 3x is a 1 upon 3 log of sec of 3x minus 1 upon 2 log of sec of 2x minus log of sec of x plus c, and therefore I is equals to 1 upon 3 log of sec of 3x minus 1 upon 2 log of sec of 2x minus log of sec x plus c. This is the answer. Now the next is a problem number 14. I is equals to sin of x raised to 5 into cos of x raised to 8 dx. Again, this I is equals to integral sin of x raised to 4 into sin x cos of x raised to 8 dx. Now here sin of x raised to 4 can be written as sin square x bracket raised to 2 cos of x raised to 8 into sin x dx. Now this sin square x can be written as 1 minus cos square x bracket raised to 2 cos of x bracket raised to 8 into sin of x dx. Now put the value of that is the cos of x, that is t, then this is the substitution. Or you can expand this also. First of all, that is 1 minus cos square x bracket square means what? 1 minus 2 cos square x plus cos of x bracket raised to 4 into cos of x bracket raised to 8 into sin of x dx. Therefore, cos of x bracket raised to 8 multiplication minus 2 cos of x bracket raised to 10, and here is a cos of x bracket raised to 12. Bracket complete. Cos of x bracket raised to 12 in sin x is remaining into sin x. Into sin x dx. Therefore, we will substitute here cos x is equals to t. Therefore, minus sin x is equals to dt. Therefore, sin x into dx is equals to minus dt. Now, see this here, our integral will become like this. This is the t raised to 8 minus 2 t raised to 10 plus t raised to 12 bracket complete minus dt. Therefore, minus integral t raised to 8 minus 2 t raised to 10 plus t raised to 12 bracket complete dt. Now evaluate this, the integral of t raised to a, or the operate the negative sign. It's a t raised to 9 upon 9 minus 2 t raised to 11 upon 11 plus t raised to 13 upon 13 plus c. Now replace the value of t. Minus 2 t raised to 11 upon 11 minus t raised to 9 upon 9 minus t raised to 13 upon 13 plus c, and replace the value of t. That is a 2 cos of x raised to 11 upon 11 minus cos of x raised to 9 upon 9 minus cos of x raised to 13 upon 13 plus c, and get the answer. Therefore I is equals to 2 cos of x raised to 11 upon 2 upon 11 cos of x raised to 11 minus cos of x raised to 9 upon 9 minus cos of x raised to 13 upon 13 plus c. Again there is a correction in the answer, I think. If you are agree, then write down this as my answer. Otherwise you follow the answer from the textbook. Now see this next. The same thing is I am writing here, problem number 14. I is equals to integral sin of x into sin of x raised to 5 into cos of x raised to 8 dx. This sin of x raised to 5 can be written as sin of x raised to 4 into sin x into cos of x raised to 8 dx. Sin of x raised to 4 is sin square x bracket square into cos of x raised to 8 into sin x dx. Now here sin square x is written as 1 minus cos square x bracket square into cos of x raised to 8 into sin x. Now expand this 1 minus 2 cos square x plus cos of x raised to 4 into cos of x raised to 8 into sin x dx. Again the multiplication of the terms are cos of x raised to 8 minus 2 cos of x raised to 10 plus cos of x raised to 12 into sin x dx. Put cos of x is equals to t minus sin of x into dx is equals to dt. Therefore sin of x dx is equals to minus dt. Therefore our integral becomes, that is I is equals to integral t raised to 8 minus 2 t raised to 10 plus t raised to 12 minus dt. Here is a minus sign, integral t raised to 8 minus 2 t raised to 10 plus t raised to 12 dt. Now their integration t raised to 9 upon 9 minus 2 t raised to 11 upon 11 plus t raised to 13 upon 13 plus c. Replace the value of the t, that is a 2t t raised to 11 upon 11 minus t raised to 9 upon 9 minus t raised to 13 upon 13 plus c. What is the value of t? T is a cos x. Therefore 2 cos of x raised to 11 upon 11 minus cos of x raised to 9 upon 9 minus cos of x raised to 13 upon 13 plus c, and this is my answer. Again I say that if you are agree, then write down this answer. Otherwise follow the answer from the textbook. Now the next question, that is a question number 15. I is equals to integral 3 cos square x 3 raised to cos square x into sin of 2x dx. Very simple example. Now here we'll put here, that is a cos square x is equals to t. Its derivative is a 2 cos square x into derivative of cos x is a minus sin x dx is equals to dt. That is a minus 2 sin x into cos x into dx is equals to dt. That is nothing but the minus sin of 2x, or sin of 2x into dx is equals to minus dt. Therefore our integral becomes I is equals to minus 3 raised to t into dt minus 3 raised to t upon log of 3 plus c. Replace the value of t. Therefore I is equals to minus 3 raised to cos square x upon log of 3 plus c. And this is the answer. Now see this again. Here I will show this problem. That is problem number 15. I is equals to integral 3 raised to cos square x into sin of 2x dx. We substitute here cos square x is equals to t. Derivative of cos square is a 2 cos x and the derivative of cos of x is a minus sin x dx is equals to dt. Therefore minus 2 sin x into dx is equals to dt. That is sin of 2x into dx is equals to minus dt. I is equals to minus integral 3 raised to t into dt minus integral of 3 raised to t is a 3 raised to t upon log of 3 plus c. Replace the value of the t, that is a cos square x, minus 3 raised to cos square x upon log of 3 plus c, and this is the answer. Now the next problem is problem number 16. That is I is equals to sin of 6x upon sin of 10x into sin of 4x dx. Now sin of 6x can be written as sin of 10x minus sin of 4x. Now here is integral sin of a minus b. Its a formula is sin a cos b minus cos a sin b. That is sin of 10x into cos of 4x minus cos of 10x into sin of 4x upon sin of 4x into sin of 10x into sin of 4x dx. Split up this. That is integral sin of 10x into cos of 4x upon sin of 10x into sin of 4x minus cos of 10x into sin of 4x upon sin of 10x into sin of 4x dx. Sin of 10 get cancelled. You will get integral cos upon sin, which is the cot of x. And here is a sin of 4x get cancelled, cot of 4x, and is a minus cot of 10x dx. And their integrals are, that is 1 by 4 log of sin of 4x minus 1 by 10 log of sin of 10x plus c this is equals to 5 by 20. We find out the LCM, that is 4 and 10. 5 by 20, that is the log of sin of 4x. Here is a 2 upon 20 log of sin of 10x plus c, and here is a 1 upon 20, take the common, that is the log of sin of 4x. It will become log of sin of 4x raised to 5 minus log of sin of 10x raised to 2 plus c. And one more simplification, that is a 1 upon 20 log of sin of 4x raised to 5 upon sin of 10x square, sin square 10x plus c, and this is the answer. Therefore I is equals to 1 upon 20 log of sin of 4x raised to 5 upon sin of 10x raised to 2 bracket complete plus c. Now the again you see this here, problem number 16, integral sin of 6x upon sin of 10x into sin of 4x. Sin of 6x can be written as sin of 10x minus 4x. Separate this. Sin of A minus B, sin A cos B minus cos A sin B. Integral sin of 10x into cos of 4x upon sin of 10x into sin of 4x minus sin of 10x into sin of 4x upon sin of 10x into sin of 4x. You will get sin of 10 get cancelled. You will get cot of 4x minus cot of 10x. What is the integral of cot of 4x? That is the log of sin of 4x upon 4. Integral of cot of 10x is 1 upon 10 log of sin of 10x plus c. What is the LCM of 4 and 10? Because our answer in another fashion. Therefore, we can manage it. The LCM of 4 and 10 is 20. Therefore, 1 by 4 can be written as 5 by 20. Log of sin of 4x minus 2 upon 20 log of sin of 10x plus c. Take 1 upon 20 as a common. Here is a log of sin of 4x raised to 5 minus log of sin of 10x square plus c, and therefore here is a 1 upon 20 log of sin of 4x raised to 5 upon sin of 10x square plus c, and therefore I is equals to 1 upon 20 log of sin of 4x raised to 5 sin of 10x raised to 2 plus c, and we get the answer. Now the last question, that is the question number 17. I is equals to integral sin x into cos of x cos cube x upon 1 plus cos square x dx. Now put here cos of x is equals to t. Therefore, what's it's a derivative minus sin of x into dx is equals to dt. Therefore, sin x into dx is equals to minus dt. Therefore, I is equals to integral, that is a t cube upon 1 plus t square minus integral t cube upon 1 plus t square dt. Now the numerator has the power 3, which is divided by 1 plus t square, that is a t cube upon 1 plus t square. The division is like this. First division is the division of the t, that is a t cube plus t minus t. Therefore, I is equals to minus integral t minus t upon 1 plus t square into dt. That is a t square upon 2. This is the first. T upon 1 plus t square. Now this integration is very simple. That is a, we will adjust, that is a 2 multiplied 2 divided by 2. That is a 2t upon 1 plus t square. That is a minus t square upon 2 minus 1 upon 2 log of 1 plus t square plus c. And therefore that minus minus will become plus. And here is a 1 upon 2 log of 1 plus t square minus t square upon 2 plus c. Therefore, I is equals to 1 upon 2 log of I is equals to 1 upon 2 log of 1 plus t square minus t square plus c. Replace the value of the t, that is 1 upon 2 log of 1 plus cos square x minus cos square x plus c. This is I is equals to, and again there is a correction in the answer. Therefore, this is my answer. If you are agree, then write down this answer. Otherwise, you follow the answer from the textbook. Now again, see this. The same problem is here. I is equals to integral sin x into cos cube x upon 1 plus cos square x. Substitution, put cos x is equals to t. It's a derivative minus sin x into dx is equals to dt. Therefore, sin x into dx is equals to minus dt. Therefore, I is equals to minus integral t cube upon 1 plus t square dt. Now divide this t cube upon 1 plus t square multiplied by with t. Then you will get t cube plus t, subtract it. Then you will get this plus t square minus t square get cancelled, you will get minus t. Therefore, I is equals to minus integral. This is a t minus t upon 1 plus t square. What is the integral of t? It's a t square upon 2. This minus minus will become plus 1 upon 2. That is adjust to there. 1 upon 2 integral 2t upon 1 plus t square dt. Therefore, minus t square upon 2 plus 1 upon 2 log of 1 plus t square plus c. And this is that is 1 upon 2 log of 1 plus t square minus t square upon 2 plus c. Again, replace the value of the t, that is I is equals to 1 upon 2 log of 1 plus cos square x minus cos square x plus c. And here is the correction. This is again my answer. If you are agree for my answer, then write down this. Otherwise, follow the answer from the textbook. And in this way, we have completed the exercise 3.2a. Now we'll see the next video. Till then, goodbye.